The last lecture we have started with the interpolation. We have seen the Newton's forward difference formula and Newton's backward difference formula to find the missing value or to predict the value which is not in the range. Okay. So basic requirement for the Newton's forward difference formula and backward difference formula is the data must be equally spaced. Okay. What if the data is not equally spaced? Okay. Then we use the Lagrange's interpolation formula. Okay. So Lagrange's interpolation formula gives us the interpolating polynomial. Okay. If we have n observations, we get n minus 1 degree polynomial. To interpolate the given data and to find the missing figure, which may be in the interval, which may be out of the interval. Okay, so let us try to understand the Lagrange's interpolation formula. So I hope you are able to see this.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay, so what we have let x0, y0, x1, y1, x2, y2, so on the terms xn, yn be the given data. Okay, so the Lagrangian polynomial or Lagrange's interpolation formula is given as. So what we have, the interpolating polynomial p of x, okay, equal to. So this is x minus x1, x minus x2, and so on the term x minus xn upon x0 minus x1, x0 minus x2, so on the terms x0 minus xn into f of x0, or this f of x0 is going to be by 0. Okay. Or I write here, this is y0. Okay. Plus, we have the next term as x minus x0, x minus x2, x minus x3, so on the term x minus xn. And in the denominator we have x1 minus x0, x1 minus x2, x1 minus x3, and so on the term x1 minus xn, and here we have y. And we can construct the terms. Okay, so general ith term is given as x minus x0, x minus x1, so on the terms x minus xi minus 1, x minus xi plus 1, and so on the term x minus xn upon xi minus x0, xi minus x1, xi minus xi minus 1, xi minus xi plus 1, and so on the term xi minus xn. And now we can have all the terms, and the last term is as x minus x0, x minus x1, so on the terms x minus xn minus 1 upon xn minus x0, xn minus x1, and so on the term xn minus 1, and here y. Okay, so this is the formula for the Lagrange's interpolation polynomial, or this is also called as Lagrange's interpolation formula. Okay, so in construction, we need to understand that, see, in the first term, we don't have x minus x0 term in the numerator. So all the terms in the denominator will be x0 minus all x sides. Here, we don't have x minus x1 term in the numerator, but all the denominator terms will be x1 minus xi, where I is not equal to 1. And like that, we have to construct all the terms. Okay. And these terms will give the n minus 1 degree polynomial, which we call as Lagrange's interpolating polynomial. Okay, so this we can understand better with the help of example. So is there any doubt in this polynomial or in this formula? All of you are getting this formula?
Yes, sir.
Okay.
Yes, sir.
That's good. Okay, so let us try to have an example based on this. Okay, so let us see the example. Go for the example. Find the Lagrange's interpolating polynomial for following data. So here the data is given. We have x and y. Zero, 1, 2, 0, 1. We have. So this is the data given, and hence find the value of y at x is equal to 4. Okay. So this is here. Let's find out the Lagrange's interpolating polynomial and then value of y at x is equal to 4. So we have the following data. Okay. So let us consider this data. What we got here? Of x and y. So it is 0, 1, 3, 0, 1, 0. So here we can see that these values of x are not equally spaced. Okay, 0, 1, the difference is going to be 1. 1 and 3, the difference is going to be 2. And again, we have to find out that x is equal to 4. So again, 3 and 4, the difference is going to be 1. So they are not equally spaced. And hence, we cannot use the forward difference formula as well as the backward difference formula, because when we define the difference, okay, it is for the regular interval or for the fixed size of the interval. Here, this data is not equally spaced, so we have to use the Lagrange's interpolation. Okay. So here, what we need to understand, we have to always start with 0. So this value is x0, this is x1, and this is x2. This is y0, this is y1, and this is y2. Okay. Now, Consider Lagrange's interpolation formula. Okay. So what we have here, we have the three values. Okay. So we have to write the formula using these values. So what we get here, P of x equal to. Okay, so this is a polynomial, that's why we are writing P of x. So first term will be x minus x0, x minus x1. But here we are using x0, so first term will be x minus x1.
Cancel.
Yes.
Yes,
Okay,
sir.
so first term will be x minus x1, then x minus x2, and this term corresponds to the x0. So you'll be having x0 minus x1, x0 minus x2, and here you'll be having y0 plus. Now this term corresponds to x1. So x minus x0, x minus x2, and here we have x1 minus x0, x1 minus x2, and here we have y1 plus. This term corresponds to x2. So x minus x0, x minus x1, and here we have x2 minus x0, x2 minus x1, and we have here y. Okay, so we have benefit that this term is also 0 and this term is also 0. Okay, so y0 is also 0 and y2 is also 0. So this term will be 0, this term will be 0. So we have to think of this term only. But we'll write the values for understanding. So x minus x1, that is 1. X minus x2, that is 3. Here we have x0. X0 is 0. So it is 0 minus 1, 0 minus 3, and y0 is 0 plus x minus 0, x minus 3, and here we have this x1. So x1 is going to be 1. So 1 minus 0 and 1 minus 3, and y1 is 1 plus here we'll be having x minus 0, x minus 1. Okay, this is what we have here. Now see, this is x2. So it is 3 minus 0 and 3 minus 1, and the value of y2 is going to be 0. Okay, so I hope you are getting the construction of these terms. So is there any doubt in these terms? Are you getting these terms? Yes.
Yes, sir.
Okay.
Yes, sir.
Good. Okay, so here this term is going to be 0. So this is 0 plus here you will be having x and x minus 3 upon. What is the term you will be having here? 1, and this is minus 2. And here we have 1. Okay. Now see, this term is again 0 because we have 0 here. So we got the polynomial in x as x square minus 3x, and this is going to be minus 2. So can I write this as 3x minus x square by 2? Are you getting this?
Yes, sir.
Okay. So this is the required Lagrange's interpolating polynomial. So we got P of x is equal to, right, half
Sir,
of
can you please scroll up a little?
x minus x square. Yes, is the required Lagrange's interpolating polynomial. Okay, so this is the polynomial. Yes. Okay. So here in the first term we have this 0, so this term will be 0. Here in the last term we have this 0, so this term will be 0. So only term remains is the second term, and that's why we simplify it. So we are able to get this one. Okay. Now see what happens to if I put x is equal to 0. So what will happen if I put x is equal to 0? Will it be 0?
Yes, sir.
Yes. If I put x is equal to 3, what will happen? Will it be 0 again?
Yes, sir.
Yes, sir.
Yes. So it is satisfying this value. Put x is equal to 1. If I put x is equal to 1, what will happen?
1.
So this is going to be 1. And that is what the given value is. So that means this polynomial satisfies all the tabulated values. Okay. This polynomial satisfies all the tabulated values. Or in other words, this curve passes through all the given points. Okay. This curve passes through all the given points. Or this polynomial satisfied all the given values. So this polynomial satisfies all the given values or given points. Okay, so our first task is completed, right? So here we wanted to find out interpolating polynomial, and then we got the interpolating polynomial. Now we have to find out, hence find the value of y at x is equal to 4. Okay, so we have to find out the value of y at x is equal to 4. And hence what we can say is at x is equal to 4, we get. Okay, so what we are able to get is p of 4 is equal to, or this is equal to y at 4. Okay, so we want to find out the value of y at 4. This is half of 3 into 4 minus 4 square. So what is we can have? This will be half, and you will be having this is 12 minus 16. So it is half of minus 4 is the minus 2. So can I say that polynomial, the value of polynomial at 4 is y at 4. Is that equal to minus 2?
Yes, sir.
Okay.
Yes, sir.
So correct. We got the value of y at, and if you can see, this is going to be a parabola. Okay. So we can have, this is going to be a parabola. Okay. We get the value of this interpolating polynomial at x is equal to 4, and that is going to be minus 2. So at x is equal to 4, y will be minus 2. Okay, so is there any doubt this question?
No, sir.
No, sir.
All of you got this one? Yes.
Sir, can you please repeat when to use Newton's formula and when to use Lagrange's formula?
Correct. Okay, so when the data is equally spaced, okay, if the data is equally spaced, then we have to use Newton's forward difference formula and backward difference formula. If the data is not equally spaced, then we have to use the Lagrange's interpolating polynomial or Lagrange's interpolation. Got it?
Yes, sir. Thank you.
Okay. Okay. That's good. So now, if you don't have any doubt in this question, then we'll go for the next. Okay. So let us go for the next question. Okay. So we go for the next question. Fine. We can say interpolate the value of x is equal to 4, value at x is equal to 4, the data is here we have x, we have x. Okay. 2, 3, 5, 8, and we can have and we have the values 10, 3, 8. Then, so this is the example. Now here we have to decide which formula we should use. So look at the data and tell me what formula you need to use.
Lagrange's interpolations.
Correct. Consider the given data. Okay. So what is the data given? Always write the given data so it justifies why you have chosen the particular method. Okay, or you need to mention the method. So here we have going to be 2, 3, 5, 8, and 12. So this is 10, 15, 20, 40, and 80. Okay. So now see what we got here. This is the data, but you can see 2, 3. So the difference is going to be 1. 3 and 5, the difference is 2. 5 and 8, the difference is 3. 8 and 12, the difference is 4. So that means this data is not equally spaced. Okay, so this data is not equally spaced, and hence we need to understand that we cannot use the Newton's forward difference formula or backward difference formula here. So we have to use the Lagrange's interpolation. Okay, and hence we use the Lagrange's interpolation. So we have Lagrange's interpolation formula as. Okay, so what we have here, this is f at x0. This is x0, x1, x2, x3, x4. Okay, and so we got here, this is f of x1, f of x2, f of x3, and f of x4. Okay, so what we have here, this is p of x is equal to, okay, the polynomial. You see, we have x minus x1. This term is corresponding to x0, so we will not take x0. Okay, x minus x2, x minus x3, x minus x2. Now, here we have x0 minus x1, x0 minus x2, x0 minus x3, x0 minus x4. And here we have f at x plus x minus x0. This term corresponds to x1. So we omit x1. So x minus x2, x minus x3, and x minus x4. And here we have x1 minus x0, x1 minus x2, x1 minus x3, x1 minus x4, and we have f of x1 plus x minus x0, x minus x1. This term is corresponding to x2. So x minus x3, x minus x4. And here we have x2 minus x0. x2 minus x1. x2 minus x3. x2 minus x4. And we have here therefore x2 plus x minus x0, x minus x1, x minus x2, x minus x4. This term is corresponding to x3. So we have x3 minus x0, x3 minus x1, x3 minus x2, x3 minus x4. And we have therefore x3. Now, the last term what we have here, x minus x0, x minus x1, x minus x2,
Sir, it will be f of x3.
x minus
You have
x,
written x of x4. On the right, sir.
yes. Okay. So this will be x3. Okay, this is x3. Okay, and now here we have this is x4 minus x0, x4 minus x1, x4 minus x2, x4 minus x3. Now we have of x4. Good. Okay. So now it's okay. Are you getting the construction of this formula?
Yes, sir.
Yes. Okay. So now we have to put all these values. Okay. So let us put these values. Okay. So we can have 3, 5, 8, 12 in the numerator. Okay. So we get here hence p of x is equal to m. So we got here x minus, in what are the values? It is starting with 2. So this is x0, 3, 5, 8, 12. Okay. So x minus 3, x minus 5, x minus 8, x minus 12. And here, this is 2 minus 3, 2 minus 5, 2 minus 8, minus 12. And f of x0. So what is the value of f of x0? It is going to be 10. Okay, so we got here. This is 10. Okay. Now we have here plus x minus 2, x minus 5, x minus 8, x minus 12. So this term corresponds to x is equal to 3. So 3 minus 2, 3 minus 5, 3 minus 8, 3 minus 12. And we want f of x3. So is it 15? Are you getting this?
Yes.
So this is the 15 we are taking from the table. Okay. So I hope you have written the table. Next. So this term corresponds to x is equal to 5. So x minus 2, x minus 3, x minus 8, x minus 12. And here 5 minus 2, 5 minus 3, 5 minus 8, 5 minus 12. And this value corresponding to x is equal to 5. So what we have, x is equal to 5, 20. Okay, so that's going to be 20. Plus, now this term corresponds to 8. Okay, so x minus 2, x minus 3, x minus 5, x minus 12. Now 8 minus 2, 8 minus 3, 8 minus 5, 8 minus 12, and this is going to be 40 plus. We got x minus 2, x minus 3, x minus 5, x minus 8. And here we have, this is 12 minus 2, 12 minus 3, 12 minus 5, 12 minus 8. And we got here 80. So all of you got this construction.
Yes, sir.
All of you got this. Now we have to calculate. Okay. So let us calculate. And hence we have p of x is equal to. So here in the numerator, first we'll try to calculate the quadratic polynomial, and then we try to calculate the fourth degree polynomial. So if I calculate the product of these two first, okay, so is it x square minus 8x plus 15? Getting this? The
Yes,
product
sir.
of first two terms. I am taking two terms at a time. I am not taking four terms or at a time. So I am taking two terms at a time. Then into this will be x square minus 20x. Okay, plus what you can have? Is it 96? Are you getting this?
Yes.
Yes. So now see this denominator. So it is going to be minus 1. This is minus 3. This is going to be minus 6. And this is going to be minus 10. And here we have 10 plus. Now think of the next term. So we can have x square minus 7x plus 10. X square minus 20x plus 96. On we have here 1. This is minus 2, minus 5, and minus 9. And here we have this going to be. Okay, are you getting this term? Now see the next plus. So we got here x square minus 5x plus 6, x square minus 20x plus 96. And here we have, this is 3, this is 2, this is minus 3, and this is minus 7. And this term is here 20 plus. Now here we have x square minus 5x plus, you can have 6, and here it is x square minus 17x plus 16. On see this term, so it is going to be 6, this is 5, this is minus 3 and minus 4, and into 40. Are you getting this term? Is that okay?
Yes, sir.
Now, x square minus 5x plus 6, x square minus 13x, and plus 40. And here
So
we
it would
have
be minus 3 in the denominator of the previous term. It should be just 3, no?
this is going to be 6. Yes.
Yes, sir. But just
Yes. So now think of the next term. So what we got here? Here we have, this is 10, this is 9, this is 7, and this is 4, and here we have 18. So what is terms? Third again.
Yes, sir.
Now we have to simplify the numerators and denominators. Okay, then we can get the polynomial. Okay, so let us think of the numerators one by one. Okay, so here multiply these two polynomials. So we can say x raised to 4 minus 8x cube plus 15x square. Okay, so I'm multiplying by this x square. So we got x raised to 4 minus 8x cube plus 15x square. Then we'll be having minus 20x cube. Okay, so minus 20x cube. Then you'll be having minus minus plus 160 x square. Then you'll be having minus. So it is going to be 300x. Are you getting this term? So we are multiplying these two terms, minus 20x and plus 15. Okay. Now plus 96x square. Okay, minus. So give me what you'll be having, how much x you'll be having here?
$768.
Is going to be this is all you have,
768.
768. And the next value
1440.
1440. Okay. The denominator, how much you can have? We can cancel this 10 with this 10. Okay, and minus, we have 4 minus, so we can have plus. So
So it will be 18.
yes, it is going to be 18. So this 10 we have cancelled with this 10. Right? Now think of the next term. Okay, so we have to think of this term. So we can have plus.
It will come minus.
We have x raised to 4 minus 8x cube.
No, sir. The plus which you wrote now will be minus.
This term is going. This is going to be minus.
Yes, sir.
Yeah, we can have this all minus here. So we can write it as minus also. Okay. So if we consider these 3 minuses, then we can have it minus. Okay. So let us simplify the numerator. Okay. So what is in the numerator? Again, x raised to 4. Okay. Minus 7x square cube plus 10x square minus 20x cube plus 140x square, and we'll be having minus 200x, then plus 96x square. Okay, minus how much x you will be having here? 96 into 7. X, and this plus 960.
672, sir.
It is going to be 612,
672.
672. Okay. Good. Okay. So now the denominator. So what is in the denominator? We have 5 we can cancel, and 1 3 also. Okay, so 5 is cancelled, 1 3 is cancelled, so 3 2s are 6. Is that okay? Are you getting this?
Yes, sir.
Because here we have 15. If I cancel 5, this 5 will get cancelled. I'll be having 3. So this 3 I'll cancel. Here I have another 3. So 3 2s are 6. Right? Okay. So now we have to think of this term. So this minus minus is going to be plus. So we can have this plus. And you'll be having here x raised to 4. Okay. So we got here x raised to 4. Then minus 5x cubed plus 6x squared minus 20x cubed minus minus plus 100x squared minus 120x plus 96x squared minus 5 times 96. How much you have?
576.
576. Oh. 5 times 97, 96.
480.
Yes, sir. Sorry.
Okay, so that's going to be 480. And then plus. Okay, what do you have? 96 times 6. What you have?
576.
573.
576.
576. Okay, so this is 576. Now see, we have 20 here. So how much you are able to cancel? Just 2. Okay, because we can cancel 2. So I'll be having 10 here. Okay. This 2 is cancelled. So 3 3s are 6, 6 7s are 48. Is that okay? Are you getting this term? Is that okay?
Sir, it will be 60.
See, here we have 20. Okay, so we have cancelled this 2. That means here we'll be having 10. Okay, so this will be this will be 49. This will be different. Okay. So what we get here?
So it will be 63 in the
It
denominator.
will be 63. Correct. Okay. So this is going to be 63, right? Now see the next. What is the next term we have? This one. Okay. So let us multiply this. We can have again. We can see there is only one minus, so we can consider this directly minus. And we have x raised to 4. Okay. 5x cubed 6x squared minus 5x cubed plus 6x squared. Then what do we have here? Minus 17x cubed. Okay, so minus 17x cubed. Then this will be minus minus plus. So what is the next term we'll be having here? The product of these two. What will be having? 17 paisa. How much you have?
85.
85.
85x square. Okay. Then 17 6
102.
102x. So we're going minus 102x. So this is now we have to think of this 16. So 60x square. You can have plus 60x square minus 300x and plus. So is it 360? So this will be 60 into 5x. So it is minus 300x and 60 into 6. So it is going to be 360. Okay. Now here we have 40. Okay. So can we cancel this 40 and we can have 9 as a denominator?
Yes, sir.
Okay, see here, if I cancel this 4, then I'll be having 10 here. If I cancel this 5, then I'll be having 2 here. And if I cancel this 2 from here, I'll be having 3 here. So 3 3s are 9. So that means in the denominator, I'll have 9. Okay, now the last term. Okay, so think of this last term. So we can have x square multiplied by x square. All the terms are positive, so this will be plus. So it is going to be x raised to 4 minus 5x cube plus 6x square. Okay, that's what we can have. Now multiplied by minus 13x. So this will be minus 13x cube. Okay, then this will be plus 65x square. We can have plus 65x square. Is that okay? Are you getting this? Now,
Yes.
this
Yes.
minus, how much you have? 78 minus 78x. Are you getting this? Now we have to multiply by this 40. So we can have plus 40x square. So this is plus 40x square minus 200x and plus 240. Is that okay? Are you getting this? Here, this will be 6 into 40. So it is going to be 240. 5 into 40, it is going to be 200. Now see this 80. So can we cancel? How much you are able to cancel? So 10, so it will be 8. 4 we can cancel, so it will be 2. Okay. And here 10 and 4 are got cancelled. So is this 63 again?
Yes, sir.
63, and here we have 2. What this one? Is there any doubt up to this one? So these are the 5 terms that we have got. Okay. Now in first term we have to sort according to the power of x. Okay. So we have x raised to 4, it remains as it is, but we have 2x cube terms. We have to sort this, and we have 3x square terms. So we have to sort this again. We have 2x terms, so that we have to consider. Is that okay? So let us sort this. Okay. So we can have p of x is equal to. We got x raised to 4. First term. What you will be having is that minus 28x cube. Are you getting this?
Yes, sir.
Minus 28x cube. Okay. So here we have minus 28x cube. What about x square? So this is 15x square plus 160 plus 96. Okay, so how much you have? 15 plus 160
71.
is going to be
271.
271. So we'll be having here plus 271 x square. What about x?
1068.
1068. Okay. So this will be minus 1068x. What about the constant term?
It is 1440.
1440, right? So it is 1440. And this all the term divided by 8. Next term is minus. Okay. So think of this term. You'll be having x raised to 4 minus how much x cube we can have? 27x cube plus x square. How much x square you can have?
246.
246 x square. How many x we have?
872.
872x. What about the constant term? 960. So all term divided by 6. Now think of the next term. So we're having plus x raised to 4 minus, is that 25 x cube plus how many x square we have?
202.
202 x square. What about x?
600. 600.
600x. What about the constant?
576.
576. And all this term is multiplied by 10. Okay. And divided by 63. Next term is minus. Okay. So we can have x raised to 4 minus 22 x cube plus x square. How many x square we can have?
151.
151 x square minus how many x we have?
402.
402x plus 360.
360.
This term is divided by 9. Okay. Now we have the next term plus. Okay. So what is the term here we have? X raised to 4 minus 18x cube plus how many x square?
111.
111 x square minus what about
278.
78x plus this is going to be 40 and hence divided by or going to be divided by 63 and multiplied by what is the number we have? 2 multiplied by 2. Okay, so now we can think what is going to be the LCM of all these terms. Okay, so we have P of x is equal to what can be the LCM? So we have number 6, we have 18, we have 63. So 9 is already included in 18 and 63. So we don't have to think of 9. 6 is already in 18. So we don't have to think of 6. What will be the LCM for 18 and 63?
One 26.
Going to be 126.
126.
Okay. So if I have 126 as the denominator, okay, then how much we have to multiply here?
By 7.
7.
Yes.
Okay. So 7 times x raised to 4. Okay. Right here, this is 7 times x raised to 4 minus 28x cubed plus 271x square minus 1068x plus 1440 minus. Here, what will be the multiplier?
21.
21. So we can have 21 times. Okay. So here x raised to 4 minus 27x cubed minus plus 46x square minus 872x plus 960. Okay, what will be the multiplier here? See, 2 will be the multiplier. Already we have 10 here. So I'll write directly 20 here.
20.
Okay, x raised to
Yes.
4 minus 25x cubed plus 202x square minus 600x plus 576 minus, what will be the multiplier here? What will be the multiplier here?
14.
14. Okay, so we got here x raised to 4 minus 22x cubed plus 151x square minus 402x and plus 360. Now we can have plus. So again multiplied by 2. So I'll be having 4 here. So it is x raised to 4 minus 18x cubed plus 111x square minus 278x plus 2. Okay, so this is what we have to solve. Okay. So I want a final polynomial in terms of x raised to 4 and all. So we'll write this as 1 by 126, and here we can have this. So what do you can have? This will be 7x raised to 4 minus, how much you will be having here?
196.
196 x cubed plus, the term you will be having here?
One 1897.
1897x square. Next,
7476x.
7476x. Next,
10080.
10080. Okay, now minus this. So minus 21 x raised to 4 plus, what will be having the term here? What is the term we have here?
567.
567 x cubed Okay, minus. What is the term here you'll be having? Four six into 21.
Five and six.
By 1.
Five and six.
5166. Okay, x square. Then you'll be having plus. How much x you will be having here?
18312.
18,312.
It's going to be
18,312.
12.
312.
Okay. It's 212 or 312?
312.
312.
312, sir.
312, no? So minus. What this figure will be?
20160.
20160.
0160. Okay. The next. So this term we're having plus 20x raised to 4. Okay. Minus 500 x cube. Okay. Plus is going to be 202. So is that 4040?
Yes, sir. Yes.
4040 x square minus. So what you'll be having here? So it will be
12,000.
12000 x and plus. What this term is going to be?
11,520.
Is that
11,520.
11520? Okay. Now the next term. So it is minus. Okay, 14x raised to 4. Minus minus plus. So what this figure will be?
308.
It's going to be
308.
308 x cube minus 151 into 14.
2114.
2114. Okay, x square minus minus plus 402 into
56. 5628.
5628. Okay, x and minus
5040.
340. Okay, this is a constant. Okay, now plus. So this is 4x raised to 4 minus. We'll be having, is that
72.
22 x plus. We'll be having 444 x square minus. How much is this going to be?
1112.
1112 x, and this is going to be plus.
960.
Is that
960.
966.
960. Okay. Now we have all the corresponding powers, and hence we can write P of x is equal to 1 by 126. So how much x raised to 4 we have?
Minus 4.
It's going to be minus
4, sir. Minus 4.
minus 4 x raised to 4. What about this term?
Plus 107.
Plus 107
7.
x cube. What about this term?
Eight double nine.
Minus 8
Minus 899 x square. What this term?
Plus
952.
335.
Plus or
3352.
plus
Plus
3352.
3352. Okay. 3352x. And this term?
Minus 2640.
643. Please verify
40.
your answer. 23.
2640.
2640. Please verify your answers. Almost
Yes, sir, correct. Same.
all of you have to get the same answer. Okay, so we can say this is the required Lagrange's interpolating polynomial. Okay, so as per the given data, this is the polynomial. Okay, so we got this as a polynomial. Okay, now what we want, see the question. Okay, so we have to find the value of f at 4. Okay, so the value of f at 4. Okay, so what we have to do is, whatever the polynomial that we have obtained, in that polynomial, we have to put x is equal to 4. So we write here at x is equal to 4, we have, what we are having, the value of the polynomial at x is equal to 4, or this is f of 4 is equal to 1 by 126. This is minus 4 raised to 4 plus 107 4 minus 899 4 square plus 3352 into 4 minus 2620. So this you can evaluate in one line using the calculator. So I want what is the value of polynomial at x is equal to 4, or what is the value of f of
17.52.
is going to be 17 point 17 point, some more digits,
52.
52. Okay, so what about others? Are you getting the same value or you are getting the different one?
Yes, sir. Same value.
Same, sir.
Same value.
Okay,
Sir,
so
do we
now
have to derive the polynomial or we can directly substitute initial only the value of x equal to 4?
better we derive the polynomial so that we can understand whether the polynomial is correct or not. In the last example, I have shown you how to check the polynomial. Okay, so put any value of x in the polynomial, and if it is giving the tabulated value, that means this polynomial is good. Okay, so we got the polynomial. Now, how to verify the answer is correct or wrong? Okay, so we got here 17.52. Okay, and we got this value for x is equal to 4. Okay, so the value, if we are interpolating, that means it is between the interval. Okay, so here at 3 the value is 15, at 5 the value is 20, and you can see the value is increasing. Okay, so as x is increasing, y is increasing, or f is increasing, so that means the values are increasing. Okay, so if the values are increasing, then the value at 4 by mean value theorem, it must lie between the 15 and 20. Okay, and we got the value to be 17.52. So that polynomial is good for the interpolation. Okay, so that's what we have. Do we have any doubt in this example?
Yes.
Okay, all of you got this example? Okay. So now we have used the Newton's forward difference formula, Newton's backward difference formula, and Lagrange's interpolating polynomial to find the missing value or to predict the value. Okay, so next we'll think of the numerical integration. Okay, so how to find out the integration numerically? Okay, so there are so many applications of numerical integration. When the smooth curve is not defined, okay, at that time we can have the intermediate values, and then using that intermediate values, we are able to approximate the area, we are able to approximate the depth, we are able to approximate the values of the required integration. So in numerical integration, we'll have three formulas. Okay, so first we'll try to understand the trapezoidal rule. Then we'll understand the Simpson's 1/3 rule, and then we'll use the Simpson's 3/8 rule. Okay, so let us try to understand the numerical integration. These are the practice examples you can have. Okay. So what we have, suppose we have the integral from A to B. Okay, so let I be the integral from A to B for the given function dx. Okay, now here we have to define the subintervals. Okay, so we have the interval from A to B, and here we have the value f of A, and here we have the value f of B. Now we have to divide this interval into n parts. Okay, so n is equal to number of intervals. Then we start with x0. So x0 is going to be the initial value a, and this last value is going to be xn. So we have to divide this interval a to b into n subintervals. So we can have here x1, we can have x2, we have x3. So on the term, we have xi, xi plus 1, and so on the terms. And this final value is going to be x. Here we have h is a step size. Okay, so how these terms are related? So we can have xi is equal to x0 plus I times h. So it is xi is nothing but x0 plus I times h. Or how we are able to calculate the value of h? So h is equal to b minus a by n. Okay, h is equal to b minus a by n. So n is the number of interval, whatever the number of interval we'll consider. Then b is the final value, a is the initial value. So when we write x0, it is going to be a, and when we write bn, it is going to be xn. Okay, and using this formula, we are able to write as h is equal to p minus a by n. So sometimes the step size will be given in the question, but sometimes the step size may not be given. Again, if it is given, we have to use it. If it is not given, we have to calculate it. Okay, so using this formula, we are able to calculate the step size. Okay, so when the step size is given, number of intervals may not be given, or when the number of interval is given, then the step size may not be given. So is there any doubt up to 8? So this value will be y0, this value will be yn, and this yi is nothing but the value of y at xi. Okay, what is yi? Yi is nothing but y at xi. So when I say y0, that means y at x0. When I say yn, that means y at xn. So is there any doubt up to 8? So x0, y0 is the initial pair, and x and yn is the final pair, or these are called as extreme values, extreme end values. Okay, so y0, x0 is the first end, and yn, xn is the last end. So these are also called as extreme values. Okay, then we know odd and even terms. So x1, x3, x5, these are going to be odd terms. x2, x4, x6, these are going to be the even terms. Okay, so now we first think of the trapezoidal rule. Okay, so what is going to be the trapezoidal rule?
Sir, can you scroll down a little?
Yes, sure. Okay, so is there any doubt up to this?
Thank you, sir.
Yes. Okay, so now we need to understand the first. Trapezoidal rule. Okay, so what is going to be the trapezoidal rule? So here we are familiar with all the terms now. Okay, so I hope you are able to see this, right? Okay, so here what is our assumption? Let I be the integral from a to b f of x dx be the given integral. Okay, then we have I is equal to h by 2 in bracket x plus 2r. So what is x? X is the extreme terms. So that are going to be y0 and yn. Okay, and r means remaining all terms. So y1, y2, y3 up to yn minus 1. These are the remaining terms. Okay, now when we approximate the area by using trapezoidal. So why this rule is called trapezoidal? Because we are approximating the area by using trapezoid. Okay, trapezium. Okay, and that's why this rule is called as trapezoidal rule. So in trapezoidal rule, there is no restriction on number of subintervals. Okay, very important thing. Okay, so you need to note no restriction on number of subintervals. Okay, and that means this n, which is a number of subinterval, can be anything. Okay, it can be even number, it can be odd number, it can be anything. So there is no restriction on the number of subintervals in trapezoidal rule. Okay. Now, what is the Simpson's 1/3 rule? Okay, so we'll understand the next Simpson's one-third rule.
Excuse me, sir.
Yes.
Sir, what we mean by subintervals?
Pardon?
Sir, what we mean by subintervals?
Subintervals, right? Yes. Okay.
Yes.
Yeah. So here, what we have considered, we have the given interval from A to B. Okay. So this A to B is a interval where we have to integrate this integral. Okay. Where we have to find the value of this integral. Okay. So we are dividing, we are dividing this interval A to B into smaller parts to approximate the area. Okay, and how many smaller parts we are making? We are making n smaller parts. So these n smaller parts are called subintervals of the interval AB. Got it?
Yes, sir. Thank you,
Okay.
sir.
Okay. That's good. Okay.
And sir, one more doubt.
Yes.
Sir, in the equation, it is written that x equal to y and y naught and yn. So we can write x is equal to y naught plus yn, or
X is equal to T. This is y0 is equal to f of A and yn is equal to f of B. Yeah.
no, sir. In the trapezoidal rule, sir.
In trapezoidal rule. Yes.
Here it is written that extreme values, that is
This
y
capital
naught
X,
and yn.
yes, this capital X is the extreme values. So here you can see for X, the extreme value is X0 and Xn. Okay. For Y, what will be the extreme value? It will be Y0 and Yn, no?
Yes, sir.
See, Y is equal to f of X. Okay. Y is equal to f of X. So for Y, the extreme value will be Y0 and Yn, means end values. Okay, we can say X extreme values are end values. So Y0 and Yn. Okay.
Yes, sir.
Yes.
Thank you, sir.
Welcome. Okay, so we can have Simpson's one-third rule. Okay, so first we'll try to understand these rules and then we'll try to solve the problem based on this. Okay, so what the Simpson's one-third rule says, so here we have to consider the odd term and even terms. Okay, so we have the odd terms and even terms. So our basic assumption is same. Okay, what is the basic assumption? We have a given integral. Okay, so what we have? Let I is equal to integral A to B f of x dx be the given integral. Then we have I is equal to h by 3 x plus 4 times O plus 2 times E. So x is again extreme terms, that is y0 and yn. 4 times O. O stands for odd terms. Okay. So what are the odd terms? y1, y3 up to yn minus 1. And even terms, so y2, y4 up to yn minus 2. So if I claim that yn minus 2 is even term, okay, if I claim that yn minus 2 is even term, so can you guess what will be n?
Even.
Yn minus 2, n minus 2 is even, so y is going to, n is going to be even. So this
Yes,
is the important thing that we need to understand here. So the restriction is that, note, okay, the number of subintervals n is even. Okay. So if we consider the trapezoidal rule, there was no restriction on the number of subintervals. But if you see the Simpson's 1/3 rule, then n must be even. Okay, so here what is given? N must be even. Okay, and the evaluation will be according to this formula. Okay, so next we need to understand Simpson's 3/8 rule. Okay, so what is the Simpson's 3/8 rule? Okay, so our assumption is again let I is equal to integral a to b f of x dx be the given integral. Okay, then okay, so we have Simpson's 3/8 rule as so that's what we have, the Simpson's 3/8 rule. So here we get I is equal to 3h by 8 x plus 2 times multiple of 3 and plus 3 times remaining all terms. So here what we have, extreme terms are always y0 and yn, multiple of 3. So multiple of 3 will be what? y3, y6, y9, and I claim that n minus 3 is a multiple of 3. So what you can say about n?
N is also multiple of 3.
Obviously. So n is also multiple of 3. So that means here we have the restriction on subintervals. Okay, so what we can have? The number of subintervals is, so we can say the number of subintervals n is multiple of 3. So it is,
So can you please scroll up a little?
yes. So it is multiple of 3. And so here we have the restriction that in Simpson's 3/8 rule, the number of subintervals must be multiple of 3. So in 1/3 rule, we have the restriction that n is a multiple of n is a even number. In Simpson's 3/8 rule, n is a multiple of 3. Okay. So can you guess what will be the base choice? Minimum base choice.
Even number.
So even number which is a multiple of 3. Okay, because see here in trapezoidal rule there is no restriction. Okay, in 1/3 rule it must be even, n must be even. In 3/8 rule it must be multiple of 3. So the base choice is n is equal to 6. Okay, the base choice is n is equal to 6. 6 is the minimum. Any multiple of 6 will work. Okay, but the minimum is 6. Okay, and please fix this number. Okay, so the base choice is n is equal to 6. Okay, so this is the base choice. So if I choose n is equal to 6, then I can apply any formula. So we can use 3/8 rule, we can use 1/3 rule, and we can use trapezoidal rule also. So is there any
So
doubt
please scroll up a
up
little.
to 8?
No, sir.
Okay, is there any doubt up to 8? We got this one.
Yes, sir.
We
Yes,
have
sir, got it.
trapezoidal
Thank you,
rule.
sir.
I is equal to h by 2 x plus 2r. Okay, so these are the hints you can remember. X is going to be the extreme terms, that is y0 and yn. R means remaining all terms. Okay, in Simpson's 1/3 rule, we have h by 3, x plus 4 odd plus 2 even. So O for odd terms, E for even terms. And then for 3/8 rule, we have 3h by 8, x plus 2 times t plus 3 times r. So 2 times t means the multiple of 3 and r means the remaining all terms. Okay. So is there any doubt up to 8? All of you have got this 3 rules.
Yes,
Yes, sir.
And why n is equal to 6 is a best choice? Because we want a multiple of 3 and multiple of 2 also. Even means multiple of 2. So multiple of 3 and multiple of 2, that if we consider the LCM, it is going to be 6. So 6 is the best choice for all the formulae. Okay, so when you consider, you want to consider the number of subintervals, if it is not given, then you consider 6. So you can use all the formulae. Okay.
yes.
Okay, good.